Okay, everything is being recorded. Yes. You mean in the last two problems? You mean in the from last week? So the answers were the places where the answers were wrong. Let's go over this. Where am I here? The places where the answers were wrong numerically was here when we replaced negative pi over 2 over 30, which negative pi over 60. We turned that into meters. But that's not the angle change is not meters per second. It's just radians per second. So we got the wrong numerical answer here. This is the wrong numerical answer. And the hint that something was wrong was that the units were wrong. So that's another way to check your answers. Will. The review sheet looks different?
Yeah, the review sheet looks different.
Uh-oh. Hang on. It's just one question? Do you see these other questions?
Yeah.
I didn't accidentally take no, this is the review sheet. Okay, there's an extra question or something? Can you show me? Okay, we'll do an added question. Okay, the figure below shows. Wow. Okay. I'll try to add this problem to the end. You want to hold on to this, and if we have time at the end, I'll do that problem. Okay. Anything else that's blowing up? No. Let's go. Let's do some problems. All right. And I'm recording. Let's go. Again, we're going to do it fast. It is being recorded. So now you should be able to review them on your own at whatever pace. And hopefully, how many of you looked at these problems already? Okay, good. Good. A good number of you have looked at these problems already. So all the more reason that we now it really is review. Okay, how do you do this? What's the definition of the derivative? You can see that, right? Definition of the derivative is a limit as, what should we say? U goes to 2 or H goes to 0. I think U goes to 2 will be a little nicer here. Of the function 3 over x squared plus 4 at U, which is 3 over U squared plus 4, minus the value of the function at 2. We want the derivative at 2, which is 3 over, that's a U squared plus 4, 2 squared plus 4, all over U minus 2, right? That's the definition of the derivative. We have to do a little bit of simplifying stuff here. So let's see. How shall I do this? I guess I may as well cross multiply. So this is a limit as U goes to 2. So I'll put them over a common denominator. 2 squared plus 4 is 8. So I have 3 times 8 over U squared plus 4 times 8, and then a minus 3 times U squared plus 4. And all of that divided by U minus 2. Everybody get that? So I have a fraction divided by something that's just an extra entry in the denominator. So far, so good? Okay. Again, we're going to go fast because we got a lot to cover. I want to make sure we get to everything. Okay, so there's a negative 3 that pulls out of everything. It's a limit as U goes to 2. Yeah, all right, let's pull the 3 out. Let's just keep everything together. No, I do want to pull the 3 out. I want to pull a negative 3 out. I want this U squared by itself. So let me pull out a negative 3. Negative 3, I have a U squared, and then I have a minus 4 and the minus sign I'm pulling out. So I have a plus 4 minus 8. So I get a minus 4 all over U squared plus 4 and an 8 and a U minus 2. Now I know I've done the right thing because the top and bottom are gonna cancel. Okay, everybody see that? Okay, so that's if you didn't cancel anything and you got 0 over something or something over 0, you made an algebraic error. Okay. All right. And U squared minus 4, I can write as U plus 2 times U minus 2. It's a difference of squares. The U minus 2s on top and bottom cancel. That's exactly the point. Now I should not get 0 on top or bottom if I've done things correctly. And so now I can just evaluate the limit, which is -3 times, 2 plus 2. I'll just leave it like that. 2 plus 2 divided by 2 squared plus 4 is 8. And then there's a times another 8. Okay, so I'm getting a negative whatever. We don't have to simplify this. This is the answer. It's a numerical answer. Okay, we use the definition of the derivative to figure this out. It's a good idea to check your work knowing the rules of differentiation. So if we check our work, the derivative, this is 3 times x squared plus 4 to the -1. So I get -3 times x squared plus 4 to the -2 times chain rule 2x. And I'm evaluating this at x equals 2. And do I see all the components? I see a -3. I see a 2x. When x is 2, that's 4. That's my 4 in the numerator. And I see an 8 squared in the denominator. Okay, good. So this isn't part of the problem. It's just a little aside that you can do on your own. If you've done differentiation from the definition, it's not a bad idea to do a sanity check and do it using the rules of differentiation. That's just shortcuts that you know to see that you got the right answer. Any questions on number 1? Let's go. Number 2, use the definition of the derivative to compute this other thing. Okay, I have a 4x squared minus 5x plus 1. Again, it's a limit. I think it's still better to use a u going to x now instead of 2. We're not doing this at a particular point. We're doing this in general. As u going to x of 4u squared minus 5u plus 1 minus 4x squared minus 5x plus 1 all over u minus x. Is that how you would have done it? Something like that. Okay, the nice thing is the ones cancel. And I have a limit as u goes to x of, I have a 4u squared minus 4x squared. That's a 4u squared minus x squared. I wouldn't have written down those individual pieces. I'll show you in a second. Minus, so that's this term and this term. And now I need this term, minus 5u minus negative 5x. So that's a minus 5u minus x divided by u minus x. So far, so good? And this u squared minus x squared, what I wouldn't write down is I wouldn't write down u squared minus x squared because I know I'm going to turn that into u plus x times u minus x so that the u minus x's on top and bottom all cancel. And I find that the derivative, so now I really can evaluate the limit as u goes to x is just 4x plus x minus 5. 4x plus x minus 5. The bottom is 1. Okay? That's the full derivation from the definition of derivative. Again, the algebra is a little fast. David.
I like to use x plus h.
You can use x plus h if you prefer x plus h. Yes. Then you multiply all this out. The x's will cancel and you'll get an h on top and an h on bottom. Yep, perfectly. Okay, let's do both. Limit as h goes to 0, 4 times this thing at x plus h, which is x plus h squared minus 5x plus h plus 1 minus the value at x, 4x squared minus 5x plus 1 all over x plus h minus x, also known as h.
Oh,
okay, that's the other way to do it. You do the algebra, you multiply things out, you'll get just h's left over on top and bottom, both cancel, and you'll get this in the end. What should we do once we've done it from the definition? Check. Let's do a sanity check. This is not part of the problem. It's just part of you checking to find potential mistakes. I know what the derivative is. It's 8x squared minus 5. And that is what I got. I'm sorry, 8x. Yeah, thank you. It's 8x minus 5. And that is what I got. You see, I'm writing the 2, but in my mind, the 2 is not there because I'm comparing it to this and getting this. Okay, great. Any questions on number 2? Sorry? No, question? No. Okay, let's go. Number 3, each of the limits below can be interpreted as a derivative. For each limit, determine the function and the point, and then use the rules of differentiation to compute. So if you had to compute this derivative, oh my God, this would be, I mean, this would be a very difficult limit to evaluate, but this is the derivative of a this when f of x is equal to x to the 2022 and a is equal to 2. That's exactly what the definition of the derivative would be for this function. It's a limit as u goes to 2 of u to the 2022 minus 2 to the 2022 over u minus 2. And we're using x as a dummy variable instead of u. No big deal. Okay, and I know how to differentiate this. F prime of x is equal to 2022 x to the 2021, and I'll evaluate this at x equals 2. Evaluate at x equals 2. So this limit in the end is 2022 times 2 to the 2021. Okay, that's a 2022. Any questions on that? Next, what's the function? ln of x. Yeah, what's the, so f of x is ln of x. A is 15. You can just read it off now, right? So f prime of x is 1 over x, evaluated at x equals a, evaluated at x equals 15. A is 15, is 1 over 15. Done. Next. Oh God. Oh, that's not so bad. Let's see. Cosine of 11 pi over 6. Cosine looks like this. 11 pi over 6. 11 pi over 6 is almost 12 pi over 6, which would be 2 pi, which is up here at 1. So this is going to be at the same height as 5 pi, as 1 pi over 6. It's 5 pi over 6 towards, anyway, I'm saying things. Pi over 6 is 30 degrees. Cosine of 30 degrees, if I have a 30, 60, 90 triangle, what do you guys like? A 1, the 2 is the hypotenuse, 1 is the smaller value, and across this from the 60 is going to be the larger value, and the cosine is root 3 over 2. Okay, so that's why the numerator is 0, the denominator is going to 0. So great. The function f of x is cosine. The point at which we're evaluating things is 11 pi over 6. The derivative of cosine f prime is negative sine, evaluated at x equals 11 pi over 6. Now I have to think about this. Evaluated at x equals 11 pi over 6. Now I have to draw the sine graph somewhere. Let me do it over here. The sine graph goes like this. 11 pi over 6 is over here. 11 pi over 6. Yeah. Let's try to make that readable. 11 pi over 16? No, 6. 11 pi over 6 is over here. So, well, that's the same as the negative of this value. So that's sine of pi over 6. Sine of pi over 6 is a half. So I get negative a half. Times the negative 1, which is a positive a half. So this is growing at a rate of positive a half. That makes sense. Okay. Everybody got it? Next. Compute the derivative. Oh, God. All right. How would you do this first one? A horrible sequence of, I don't know how I would do it, actually. Yeah, I think I would do logarithmic differentiation. Is that what you guys are suggesting? Yeah. Yes? Product rule. You could do a series of product rules. I'll try the logarithmic differentiation. So I get log of 2 plus 3 log of x. Ooh, that's very nice. Minus 4x, because natural log of e to the 4x is minus 4x. This is going to be a little annoying. Natural log of cosine of 5x. Right? So 1 over y times y prime is equal to, and let me just put the y on the other side already, is the derivative of all of this stuff. And by the way, what is y? Y is 2x cubed e to the minus 4x cosine of 5x. Okay, so that was the 1 over y here that I moved over there, times the derivative of what's inside. The derivative of this is 3 over x minus 4, plus here I need the chain rule, 1 over whatever, times the derivative of whatever, which is negative sine of whatever, times the derivative of what's inside there, which is a 5. That's problem A. Is that what you guys got? That's a little bit cleaner, I think, a little faster. If you have a product or like this is another one that I would do by logarithmic differentiation. Log differentiation. This one I would also do by log differentiation. This one I would also do by log differentiation. I would do a lot of these by log differentiation. Let's do one that I wouldn't do by log differentiation. Like E. E or C, what do you want to do? We're not going to do all of them. They're all kind of the same flavor. G? E. Okay, let's do E. Let's do E. So Y is sine of cosecant of 3 times e to the minus, oh God. Okay, so Y prime. There's no, it's just a chain of a chain of a chain of a chain. There's no nice thing you can do with this. Derivative of sine is cosine of whatever's inside. Cosecant of 3 e to the minus 4x times the derivative of what's inside, the derivative of cosecant. Anybody remember? Derivative of secant is secant tan. So it's negative cosecant cotan. Is that right? Yeah. Okay. And then it's what of whatever's inside, which is 3 e to the minus 4x times 3 e to the minus 4x. And now I need to differentiate what's inside here, which is 3 times e to the, so 3 times e to the minus 4x with another chain rule of minus 4. Okay, so that's this was part A. This was A. This was E. Should we do one more, or you guys have plenty of practice with differentiation? G? C. C. Let's do C. Okay, C is again a chain rule on chain rule on chain rule. Let's do C. C, I would first write F or Y, whatever, as 1 plus x to the half to the half to the half. That will make it easier to differentiate. Oh, good, I left a lot of room. Well, the outermost one is 1/2 times this whole thing to the minus a half. This whole thing is this to the half. And now I have to differentiate what's inside. Well, the 1 is a constant, so its derivative is 0. So I just have to differentiate this. That's a half times this inside thing to the minus a half. The inside thing is 1 plus x to the 1/2. This is just a matter of bookkeeping. Can you keep straight all the different pieces? Now I have to differentiate this. The derivative of this is 1/2 x to the minus a half. And again, do not simplify expressions like this. All right, there's nothing you can do with this to make it nicer. Yusuf. The inverse one. The F? Yeah. F, let's do F. Okay, so that was C. Let's do F. F, I have to write it down here. It's, what is it? X times inverse tan of square root of x. X times inverse tan of square root of x. Okay, so Y prime, product rule. I have a product of two things. First, I'll differentiate the x, that's 1, leaving alone a tan inverse of square root of x, plus, now I'm going to differentiate this, leave the x alone, x times. So here's where it's going to get tricky. What's the derivative of arctan? 1 over 1 plus the thing squared. That's the derivative of arctan. The thing is square root of x. And now I have to differentiate what's inside. The derivative of square root x is a half, again, a half x to the minus a half. And that's it. If you want to simplify this to 1 over 1 plus x. Anyway, don't simplify things like this. You got some ugly expression. Let it be. Good. You want to do any more or move on? We got the flavor of this. Was that Peter? Why is there only one with an inverse? Yeah. You should know your inverse functions. So okay, here. Let's put in. Oh no, we did that one already. Let's put an inverse on this. Okay, so here's a new version of D that I recommend you do. Secant inverse of yeah. You can take secant. Anyway, there's a range of this function where secant inverse is defined. Okay, we don't have to do all of these. Let's go. Number 5, find a formula for the nth derivative. So this is like not just first derivatives, but second derivative, third derivative, fourth derivative. Okay, you should know what this notation means. 2 derivatives, 3 derivatives, n derivatives. Okay, so the first derivative, d dx, the only way to find a formula for us right now is to just do a bunch of examples and we'll see what's going on. If we take one derivative of e to the minus 2x, we get e to the minus 2x times a chain rule of -2. If we take two derivatives of e to the minus 2x, it's the first derivative of this. So I get an e to the minus 2x and I get a -2 from the first derivative. Now I'm differentiating this. That's just a constant. Differentiating this, I get a chain rule term of another -2. Oh, I see what's going on. Every time I differentiate, a -2 comes down. So the nth, if we do this n times, we'll get e to the minus 2x, and then we'll get however many -2s as however many times we differentiated. Does that make sense? Done. Next. Okay. Find the velocity of an air conditioner. Oh God, accidentally dropped from a height of 300 meters. You're gonna kill somebody at the moment it hits the ground. All right, we're up here. Got to draw a picture. It's a word problem. I got to draw a picture. Well, I got 300 meters up here. There's an air conditioner. You guys need to like get somebody to help you install these things because there it is falling to the ground, and there goes your air conditioner. Right. What is the equation of motion? So S, our initial position, 300 meters above the ground, 300 meters. Okay, our initial velocity, 0. There's no velocity, plus 0 t. And what is the acceleration due to gravity in meters? This is not something that I would. It's minus what? 9.8 t squared over 2. Okay, the acceleration due to gravity is so acceleration due to gravity is negative 9.8 meters per second squared. Meters per second per second. Okay, so that's what we'll see here. Okay, that is the this is not a number that's 9.8. I would tell you 9.8. I would remind you 9.8 meters or 32. What is it? 32 feet per second squared. Okay, so but you should know that this is the general equation for position of a particle in free fall. There's some velocity, there's some position, and then there's the acceleration due to gravity. Okay, that's the equation. And now the question is, when do we hit 0? So we just solved this equals 0. And we want to know the velocity. Okay, so the velocity is the derivative of position. So the derivative of this is just negative. If I differentiate this, the 2 comes down, kills this 2. It's just negative 9.8 t. So the only question is, how long does it take for that air conditioner to fall? That'll tell us the speed at which it hits the ground. So how long does it take the air conditioner to fall? It falls, the amount of time that it falls, amount of time is determined by solving S equals 0. If we know when S is equal to 0, that's when we've hit the ground. S is equal to 300 minus 9.8 over 2 t squared. So I can move this to the other side. So t squared is equal to 300 divided by 9.8. So times 2 over 9.8. And the square root of that is the amount of time that it takes. And the velocity at that time. So that's the time, let's call that t0, the time when it hits the ground. So the velocity at time equal to t0, is equal to negative 9.8 times this thing, the time at which we hit the ground, 300 times 2 over 9.8. Okay, I've been sloppy with units. Position is in terms of meters. This is 300 meters. Acceleration due to gravity is meters per second squared. We have that. So that 9.8 is meters per second squared. So when we multiply by seconds squared, we get meters again. So this 9.8 is meters per second squared. Meters per second squared. And how about time? So this is meters. We're equating meters. And this is meters, this is meters per second squared. So when we move this to the other side, we actually get seconds. That's good. The meters cancel out, and the seconds, this is how many seconds we have. And so we have 9.8 meters per second squared times seconds. That's meters per second. Okay, good. Everything worked out. Will. 9.8 is a number that you have to be given. So it's a universal constant. These guys already knew it. I guess I also know it, but I would tell you the 9. I would remind you the acceleration due to gravity is 9.8 or 32 feet per second squared. Vibe.
So where did you get it? We got to do well, is it an equation, or we just like put it at the end?
You know, I think units might be. Here's a technique. I'm just kind of going off the cuff. I would do the problem with just numbers, and then I would go back through and say, wait a second, what were the units at every stage? And did I get the right units at the end for what the problem requires? So I would sort of do exactly what I just did now, reverse engineer, or after doing the problem with just numbers, go in and say, does it actually make sense in terms of the units? And that might help you catch mistakes. You should know the, so if you have a particle that starts at an initial height S0, and it has an initial velocity V0, and then it has an acceleration due to gravity, then how is it going to move? It's going to start at S0, then it's going to move with velocity, initial velocity V0 times t, and then this 98 t squared over 2 meters per second squared. The 9.8 meters per second squared is the acceleration. T squared will be in seconds. T will be in seconds. T squared will be in seconds squared. So this evaluates to meters. Okay, so this is a general formula for free fall. We had some problems about free fall. Okay. Any questions on number 6? Let's go. Find an equation for a tangent line to this graph when t is equal to that. Fine. Equation of the tangent line, I need to differentiate y prime. I have a quotient, so I'll use the quotient rule. Bottom times derivative of the top. Derivative of the top is cosine of t minus the top sine of t times derivative of the bottom. The derivative of the bottom is minus sine of t all over bottom squared. 1 plus cosine of t squared. That's the derivative. I want to know what's going on at t equals pi over 3. Pi over 3 is 60 degrees. So that's a right triangle. Here we go. A right triangle. Let's put 60 degrees here. That's pi over 3. So that's a root 3 opposite the 60, a 1 opposite the 30, and a 2 on the hypotenuse. And I need to know what its cosine is. So the cosine is a half. So this is 1 plus a half times a half minus, I guess, plus sine squared. All right. There's a simplification here, by the way. There's a cosine squared plus a sine squared that simplifies to 1, but too late now. Sine of t is opposite over hypotenuse. That's root 3 over 2 times squared. So that's 3. Let's just make this let me keep it as a, so I don't do too much at once. Divided by 1 plus cosine. Okay, so let's leave it. 1 plus a half squared. Okay, we can simplify like this kind of arithmetic. I would encourage you to simplify just because I think it will make your life a little bit easier. Okay, I have a quarter plus 3/4. These two things add up to 1, and then I have an extra half. So 1 plus a half is 3 halves. So I have 3 halves on top. And what do I have on bottom? I'll instead of dividing by a fraction, I'll multiply by its reciprocal. On bottom, I have 3 halves squared. That's 9/4. So I'll multiply by 4/9. Hopefully someone's checking this. I'm doing this kind of fast. 2/3. I get a slope of 2/3 at this point. And what is the value at this point? Y of t, when t is equal to pi over 3, is sine, which is root 3 over 2, divided by 3 halves, because cosine is a half. So that's times 2/3 instead of dividing by 3 halves. And so it's root 3 over 3. Okay, I have a point. So whatever this curve is, I have no idea what this curve looks like, blah, blah, blah. I have a point, t equals pi over 3, the height. So I have a point pi over 3 comma root 3 over 3. And I have a slope. And the slope is 2/3. M is equal to 2/3. So the equation of the tangent line will be y minus the y value, root 3 over 3, is equal to slope 2/3 times x minus pi over 3. T, it's in t's, whatever, t minus pi over 3. That is the equation of the tangent line. Any questions? How did I get the numerator where? You got 8 over 3. Okay, let's do it again. You found it? Okay. I mean, if you make a numerical error from here to here, that's like 1 point. That's not half a point, whatever it is. I'm not testing on whether your fractions, if you had to write this instead of the 2/3, there's an extra chance for you to make a mistake. So that's the kind of thing that I would simplify. Whereas a huge calculation like this kind of thing, there's just no simplifying. It's you can make it look a little nicer, I guess, but it's ugly all the way. All right. Any questions on number 7? Number 8. Compute the derivative at compute the derivative of so let's say y is equal to this thing. So y prime, chain rule, h prime of sine of x, whatever h is. I don't know what h is, times chain rule, derivative of sine is cosine of x at x equals pi over 6. So x equals pi over 6. I got to draw my triangle. Pi over 6 is 30 degrees. This is a 1, a 2, a root 3. So this is h prime of, so this is evaluated at x equals pi over 6. H prime sine is a half. Oh, good. They told us what h of a half is. H of a half times cosine. Cosine is root 3 over 2. Root 3 over 2. H of a half, we're told, is 10. So this is 10 root 3 over 2 next. Good? Next. Okay. F and G are functions whose derivative at -4 agree. And the tangent line to f at -4 is given by this. Compute the values if possible. Oh my goodness. Okay. All right. Let me first figure out what this looks like. This is 8 up here and a slope of 3. So there's my line, whatever that is. At x equals -4, 1, 2, 3, 4. -4 times 3 is -20. 4 plus 8 is -16. So we're down, whoops, negative 1, 2, 3, 4, -24. So this is the point, -4, -16, right? And y, that's the tangent line to f at this point. So whatever y is doing, it matches this value. In other words, f of -4, I already know. This is the graph of f. All I know about g is that it has the same derivative. So g could be somewhere else, could be doing something completely unrelated, but it has the same slope at that point. Okay. F prime of -4. Now I know this line. This line is y equals 3x plus 8. So its slope is 3. That means I know what this derivative is. This derivative is 3. This derivative is 3. The value of f at -4 is -16 because that is the equation of the tangent line. It's kissing f at that point. So there's my -16. This is -16. How about g at -4 could be anywhere. All I know about it is its derivative. The derivative doesn't change if you slide everything up or down. Okay, so this is if possible, not possible. Any questions? You see how you would do this one? How many would get this one? Okay, half of you are saying you'd get it. I hope the other half will practice it. All right. Does it make sense at least what we discussed? How you would come up with that? All right. Find a number a so that the tangent line to this at a and at a plus 1 are parallel. What the hell? I have a cubic here. I don't know what it looks like. It's some kind of thing, whatever. At x equals a, okay, wherever that is, and a plus 1. And I want to know that the tangent lines are parallel at these 2 points. Fine. So I need the derivative. Y prime is 3x squared plus 22x plus 1. And I want to know that the derivatives are equal. To be parallel, the slopes are the same. So I want to know when So I need to know when 3a squared plus 22a plus 1 is the same thing as 3a plus 1 squared plus 22a plus 1 plus 1. Does everybody see how I got that? That's the slope. The derivative is the slope of the tangent line at that point. If the two tangent lines are supposed to be parallel, then their slopes have to be the same. So there's my equation. I set the two things equal. This actually is going to be pretty easy. The plus ones cancel. I've got a 22a here and a 22a there. I'm about to get the 3a squareds to cancel. It's even going to be linear. So this is 3a squared. A plus 1 is 2a. I mean, a plus 1 squared is a squared plus 2a times 3 is 6a. Plus 1 times 3 is 3. And then there's a 22 left over. And on this side, I just have a 3a squared. That's even nicer. This is gone. That's gone. I got a 25 here that I moved to the other side. A is negative 25 over 6. Done. I would then plug in, just to check, I would plug in a equals negative 25 over 6 here and make sure that I get the same answer, just to make sure I didn't make a mistake. Let me not do that now in the interest of time. How many would get number 10? That's better. Okay. All right. Number 11, find the equation of all tangent lines to the graph that pass through the origin. Okay. They're getting better and better. I like these problems. I mean, you know, they're hard problems. Okay. This actually factors, right? I have an 8 and a 16. Isn't this x minus 4 squared? I don't think you had to know that. I would just draw some random parabola, but actually that parabola when x is 4 is 0. So this is 4. Okay, so here's x equals 4. So that's actually what it looks like. And I guess over here we're at 16. And the question is, what tangent lines? Okay, let's say this is going to be a little, I know a little too much now that I've seen that picture. Find the equation of all tangent lines to this graph that pass through the origin. In other words, I'm looking for a tangent line that's going to go through the origin. I'm looking for another tangent line that's going to go through the origin. My hunch is that there's going to be 2 of them. Already, because I saw that factorization, one of the tangent lines is the x-axis. And there's going to be another one over there. But we didn't know that. Let's pretend we didn't know that. All right. So, well, I don't know another way to do it, but to write down what the tangent lines are. Question? Julius?
No, I'm saying there isn't a cost, no, line.
Yeah.
That's not on the x-axis.
The truth is that it is on the x-axis. Yeah, but before I knew what it was, I would just think it's some random parabola, and then there would be those two. But the truth is actually that's going to be horizontal. Did I see another hand? No. Okay, so let's do it. What's the derivative? There's no better way to do this than to say, let's say we're at some point C, so that we aren't. Here's our parabola. So that we aren't confused about x's and c's, because we're going to want to write down what the equation of the tangent line is. So what's the derivative at x equals c? The derivative at x equals c is 2c minus 8. And so the equation of the tangent line at any point, equation of the tangent line at any point will be y minus the value, which is c squared minus 8c plus 16, because that's this point, c comma c squared minus 8c plus 16. And this slope will be 2c minus 8. So I want to figure out when does that tangent line cross through the origin. Okay, so I want to write down the equation of the tangent line first. So it's this thing is equal to slope 2c minus 8 times x minus c. What does it mean to cross through the origin? It means that when I set x and y equal to 0, this is an equation. So through the origin, I'm going to set y equal to 0. I'm going to set x equal to 0. And now I have an equation in C. So if I set x and y equal to 0, let's see. I have minus c squared. Let's move everything to one side so I don't have to deal with this minus sign. So I'm going to move this to this side so I have only plus signs. So now I have 0 is equal to c squared minus 8c plus 16. That's for moving this over. And then there's no x. There's a minus 2c squared plus 8c. Did I get that right? looks like the 8c's cancel. And one of the c squareds cancels one of the minus 2c squareds. And c is 4. C is 4 and negative 4. We already knew that c was 4. C is 4 is the point where the line is the tangent line is the x-axis. And negative 4 is the other place where we'll get this tangent going through the origin. Find the equations of all the tangent lines. So I have to find the equations. Not enough to find c. I have to write down what the equations of those two tangent lines are. So I plug in these two values of c into the equation of any tangent line. So the first tangent line will be y minus, I'm setting c equal to 4. 4 squared minus, I know what the answer is going to be anyway, but let's just write it out, is equal to 2c, 2 times 4 minus 8 times x minus c. That's one of the equations. By the way, this simplifies because this is 16 plus 16 is 32 minus 32, that's 0. And this is going to be 8 minus 8 is also 0. So that's the equation y equals 0. This is the equation y equals 0. That's exactly the x-axis. We knew that was going to be one of the tangent lines. What's the other one? And y minus, so now you put in negative 4. Negative 4 squared, I mean, I don't think you're going to have to simplify this, really. Again, I'm not testing your algebra. I want to know, do you understand what the concepts are doing? So when c is equal to negative 4, I get 2 times negative 4 minus 8 times x minus negative 4. So I'm just plugging in everywhere I see c, I'm plugging in negative 4. That's the other line. It's some line, it has some slope, negative 16. That makes sense that the slope would be negative 16, given where it is geometrically. Any questions on number, whatever number this was? 11. Make sense? Could you guys do this if this was on the test? Okay, next. Oh my God. Oh, this isn't bad. Okay, suppose that f is equal to this thing. So I have some parabola when x is at negative 2. Negative 2 is some breakpoint. I have a parabola. I don't know what it's doing, something like that. And then it's some line. And I'm guessing we're going to want the line to match up with the parabola, but let's see. Okay, limit as x goes to negative 2 from below. From below means we use the top equation. That's when x is less than negative 2. So when it goes to, that's just plugging in negative 2. So this is 6 times 4 plus 7. 6 times 4 plus 7. 6 times 4 is 24 plus 7, 31. Brain freeze. Okay, so this is the point negative 2 comma 31, at least as far as the left side is concerned. On the right side, what happens to the limit as we go to negative 2 from above? Well, then we're using this formula, and then it's just negative 2a plus b. Nothing I can do about that. Negative 2a plus b. Everybody see that? Okay, if we're going to make it to be continuous, what equation involving a and b must be true? Well, to be continuous, these 2 points have to line up. So the equation is negative 2a plus b must be equal to 31. Assuming it is continuous, compute the derivative from below. The derivative from below, so this is the limit as h goes to 0 from below of this quotient. From below, we're always going to use this formula. So it's just the derivative. What is the derivative of this function at the point negative 2? Because that's what this formula will give us. So I get 12x. So that's 12 times negative 2, which is negative 24. Assuming f is continuous, again, assuming that this equation is satisfied, what is the, in other words, so we can say what f of negative 2 is. Compute this derivative from above. From above, the derivative will be a, right? Everybody sees. Okay, so this is a. Find values of a and b that make f differentiable at negative 2. So it needs to be continuous. To be differentiable, it needs to be continuous. And I have another equation, which is that the derivatives also have to line up. So my 2 equations are a is equal to negative 24. Well, that's already easy. We're done with a. And negative 2a plus b has to be equal to 31. You guys haven't taken linear algebra yet, so we can't make this problem too complicated. So this is negative 2 times 24 is 48 plus b is equal to 31. So b is equal to negative 17. That wasn't bad at all. What do you think?
Why is A negative?
So if we look at the derivative of the left side as we approach -2, that derivative has a slope of -24. If the function is to be differentiable, that means the derivative exists. That means the left derivative agrees with the right derivative. The derivative from below, the limit from below, has to agree with the limit from above. And the derivative of this line is A. The slope of this thing is A. So A has to be -24. Does that make sense? Everybody happy with that? Okay, next. Number 13. A function, blah, 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 gives the position. So let's look at the position. It's a cubic. Okay, t goes from 0 to 4. It's some kind of cubic, whatever that looks like. I don't know. Okay, it gives the position of an object moving along. So this is time. This axis is time. And this is the position, s. Compute its velocity and acceleration. Great, we know how to do that. The velocity is the derivative of position. V of t is 3t squared minus 12t plus 10. And the acceleration is the derivative of the velocity. So I get 6t minus 12. You guys are checking this, I hope. When is the object momentarily at rest? That is when the velocity is 0. So when is the velocity equal to 0? I would just plug it into, I don't see a nice thing to do with this. I would put in the quadratic formula. So this is when t is equal to 12 plus or minus square root of 12 squared minus 4. A is 3. C is 10. Let's just see, is there such a number? This is 12 times 100 is 120. This is going to be 144. Okay, so that is a number. That all divided by, in other words, it's not imaginary. I'm not taking square root of it. If it was imaginary, that means it never is 0 in this range or in any range. When is the object momentarily at rest? Divided by 2a. A is 3. Actually, this is kind of nice, right? Because yeah, 144 minus 120 is 24. So square root of 24. Okay, 12 plus or minus square root of 24 over 6. It is what it is. Yep, we're happy with that. These are two numbers between 0 and 4. 12 is bigger than square root of 24. 12 over 6 is about 2. And this is going to be much less than, okay, so both of these are in the range 0 to 4 which is the time that we're interested in. Okay. When does the object move to the left? When does the object move to the right? Okay, so we need this velocity. So the velocity function, let's graph the velocity function. Velocity as a function of time. This is a quadratic. It's here at t. Andrew.
I just want to go back to the last one. Is 12 plus root 24 over 6 greater than
12 plus root 24. So square root of 24 is going to be 2 root 6. So 12 plus, think about it as like, the worst this is going to be is 12 plus 12. Just very crudely. 24 is less than 144. 12 plus 12 would be 24 on top. 6 on bottom is a 4. So I'm just doing some very rough arithmetic to say, yes, this is both of these values, whether plus or minus, will be positive and less than 4. Does that make sense how I did that? Okay. Velocity is going to be quadratic. Here it is, 3t squared. Oh God. I mean, there's two places where it hits 0. Okay, but those are the two places. So here's our velocity function. And at 4, what's the velocity of 4? Let's make sure we're out of the woods here. If I put in 4, I get a 3 times 4 squared minus 48 plus 10. Can I do that in my head? 4 squared is 16. 3 times that is 48. 48 minus 48 is, are we back to 10? We're back to 10. Look at that. Okay, perfect. Then we're done. Okay, so if we call these values t plus and t minus, so that I don't have to write them out again. This is t minus, this is t plus, the one with the plus sign, the one with the minus sign. Then when does the object move to the left? To the left, I've sort of written it as up and down. So really we're thinking of the object as position, let's see, s, we have to be told, s is the function moving along s axis as a function of time. So the function is like It's moving this way and that way and that way. Instead of going up and down, I've showed S as a vertical, but really S is a horizontal quantity. Does that make sense? So moving to the left means it's getting negative. To the left means it's negative, right? And so the negative values are between t minus and t plus. When does the object move to the left? That's between in t minus to t plus. When does it move to the right? It moves to the right when the velocity is positive. When the velocity is positive, S is increasing, so I'm moving to the right. And so that is at 0 up to t minus, that's this range, union t plus up to 4. That's the rest of the time. And now let's be a little careful with our brackets. So moving to the left at 0 and at 4, at t plus and t minus, it's stationary. So I wouldn't say it's moving to the right or left. So I would use open brackets here. Okay. Any questions on that? Does that make sense? Okay. When does the object change direction? Change direction. Change direction of motion. Didn't we just answer that? It changes direction at t plus and at t minus. It's momentarily at rest and then it changes direction. Okay. At t plus, at t minus and t plus. Am I missing something? Bye. I'm just being lazy and not writing this out every time. If you wanted to write it out every time, you could. Or if you want to give it notation like t plus and t minus, you could do that too. Yeah, let's say, yeah, you could say, I'll just call these t plus and t minus. So I don't have to carry them around everywhere. When does the object speed up and slow down? So that's when is its velocity increasing or decreasing? That's the acceleration. So acceleration is 6t minus 12. Let's get a graph of that going. Here's our acceleration as a function of t. What is it? 6t minus 12. So is that right? Yeah. So it starts here at negative 12 by the negative 12 dyslexia. And by the time I get to 4, 4 times 6 is 24 minus 12 is positive 12. And I'm guessing it's going to hit in that halfway point when t is 2, I get acceleration being 0. So when is it speeding up? It's speeding up when the acceleration is positive. When is it slowing down? It's slowing down when the acceleration is negative. That's in this range. And then at this instant, its velocity isn't changing. That's the instant when it doesn't feel like its chair is being pushed or pulled. Its velocity isn't changing. It's not experiencing acceleration. Okay, so when does the object speed up or slow down? It speeds up on the range 2 to 4. 2 to 4. When does it slow down? It slows down on the range 0 to 2. The acceleration is negative. It's slowing down. Its velocity is decreasing until I get to here. Then its velocity starts increasing. Does that make sense? Okay. When is the object moving the fastest, the highest speed? Well, the highest speed right here is velocity. So at the beginning and at the end is its highest speed. Highest speed at t equals 0 and t equals 4. Right? That's when the velocity is the greatest. It's moving at the highest speed. Well, let's be a little careful. Where is this bottom point? Because speed is the absolute value of the velocity. Where is this bottom point? That's at t equals 2, I guess. Everything's kind of symmetric about t equals 2. So t equals 2, the velocity is, did I do this already? No, I don't think so. 2 squared is 4 times 3 is 12, minus 24 is negative 12, plus 10 is negative 2. Did I get that right? Anybody check? So the speed here, it's negative speed, but it's a much slower negative speed than the positive speeds. When the velocity is positive or negative. Okay. When is it moving? When is the object moving the slowest? Well, this is kind of, okay, this is poorly worded because I think what it means is moving the slowest, meaning that when is the velocity the most negative? The velocity is most negative at t equals negative 2. T equals 2 rather, when the velocity is at negative 2. But if they're talking about speed, well, it's moving the slowest when it's not moving. That would be a t plus and t minus, those 2 points. So I would try to make sure that my questions aren't this ambiguous. But what they mean is t equals 2. Okay. You can infer what they're getting at. When is the velocity largest? When is the velocity smallest? The velocity is largest at 10 when t is 0 or t equals 4. The velocity is smallest at -2 when t is equal to 2. So far, so good? But there's a problem with this problem. When is the object farthest from the axis origin? Axis origin. Okay, so I'm assuming this is the axis origin. What is that farthest distance? Okay. We have several options here. Here's the actual motion. So the question is, when is it the farthest from, in other words, when is it largest? So there are places where the derivative is 0, and there's also the endpoints where it might be the farthest. We haven't really done enough of it. We're going to do a whole section on these kinds of problems. So I'm a little surprised that it's here. In fact, I'm sure that I wouldn't put a problem like this on the midterm, on this midterm. But okay, well, I would evaluate. So again, what might happen is the object might go the farthest, and then here, and then at the endpoint, it's not quite as far as it reached in this place. My guess is it's at t equals 4. Let's just see for a second. If I put in t equals 4, do I really want to do this? 64 minus 6 times 16. I can't do this in my head. Plus 40. This is some number. Then at this value we get some number, and at this value t plus and t minus we get some number, and then when t is equal to 0, it's at 0. Okay, so at least that's the value that we know. My guess is the answer is t equals 4, but I would have to take a little bit more time than I think we should now, just doing arithmetic to figure out which of these values is the optimal value. This is not a good problem for this midterm. We're not ready for this kind of question. We will have these kinds of questions. We'll be able to answer these. We'll have lots of practice answering these kinds of questions. Please. Why is it not? Well, it is based on the velocity, because when the velocity is 0, that's when it reaches the extremal values. That's what I mean by it's something that we're going to talk about a lot in the next chapter. So the extremal values are the places where you have maxes and min of the position. That's why I think we're not ready for this problem just yet. So, okay, let's take it out since I don't want to do this arithmetic and we're running out of time. Any other questions on number 13? Raga. Oh, well, it's also the solution is the slowest will be when the acceleration is 0, because that's when the velocity changes from decreasing back up to increasing. So that is the solution. Instead of looking at a picture, you just say when the acceleration is equal to 0 at t equals 2. Therefore, that's when the velocity changes from decreasing to increasing. So that'll be the smallest velocity. Again, we're going to spend a whole chapter on optimization problems. That's coming. So I think this G is a little ahead of its time. Next. Oh boy, 14, and we have a lot of problems still left. Okay, f and g are differentiable functions. The tangent line to the graph of this at x equals 11 is that. Okay, let me just draw a picture. -4 plus 9. 9 is up here. -4, I got a slope of -4. When x is 11 is what I'm worried about. At 11, I have -44 plus 9 is -35. Did I get that right? Please check these kinds of things. Okay, so there's our slope. That's the slope of the tangent line to f. So again, whatever f is doing, it's going to kiss this and move on with its life. That's f. And the tangent line to the graph of g at x equals 1, I'm going to do this somewhere else. At x equals 1 is 21. And then at x equals 1, I get a 11. 11. So these are my 2 points. And G is doing that. That's G. So here's a graph of f. Here's a graph of G. Use this information for parts A and B. Okay, let H be the composition of f and G. In other words, you do G, then you do f. Find H prime of 1. Good. H prime of x by the chain rule is f prime of G of x. Ah, I see what you did there. That 1 is 11. That 11 is the only other value we know, times G prime of x. Okay, very good. At x equals 1, at x equals 1, I get f prime of G of 1. G of, let me not write too much at once. g of 1 times g prime of 1. Okay, f prime g of 1 is 11 because of the tangent line. So this is f of 11, and g prime at 1. G prime at 1 we know. G prime at 1 is the derivative of this line. The slope of this line is negative 10. This slope is negative 10. This slope is negative 4. I'm doing this very quickly, so please check that I'm getting the right answers here. So that slope is negative 10. This slope is negative 4. That's the only value of f prime that we know. So I get negative 4 times negative 10, which is 40. 4 times 10 is 400. Okay? No. I'm losing my mind. I'm losing my mind. Negative 4 times negative 10 is 40. And then I multiplied by another 10 for some ungodly reason. Okay, let P be this other thing. Any questions on part A? Chain rule together with the information given to us. Yeah? Part B. P is this other thing. Find P prime of 11 and an equation of the tangent line to the graph of this thing at x equals 11. Oh, God. Okay. 6x sine of pi x. God. P, I got to write it down here. 6x times sine of pi f of x. Is that what P was? Yuck. P prime. You just, this is annoying. 6 times 6 times, okay, product rule. I'll differentiate x, that's a 1, sine of pi f of x, plus, let's leave the 6 as a constant out front. I'll leave the x alone. I'll differentiate this thing. Derivative of sine is cosine of whatever's inside, which is pi f of x, times the derivative of this, which is pi as a constant, and f prime of x. That's P prime. And the question is, find P prime at 11 and an equation of the tangent line at 11. Okay, find P prime at 11. Well, what is P of 11? P of 11, let's get that down, is 66 times sine of pi times f of 11. F of 11 is negative 35. Negative 35. All right, that's not going to be that hard. Sine, okay, we'll figure out what this is. This is either oh, it's 0. It's 0. It's an integer multiple of pi. Integer multiples of pi. Sine starts at 0, it hits 0, and it keeps hitting 0. So this is all 0. That's easy. Okay, good. Good. And then we want to evaluate this at x equals 11. At x equals 11. So I get 6 times. We already know that sine of pi times negative 35 is 0. This thing is 0. Plus 11 times cosine. Okay, I don't know what cosine, which cosine this is going to be. Negative 35 times pi times f prime at 11, which we know to be, what was it? Negative 4. Negative 4. Did everybody get that? Everybody see how I got that? I'm just putting together all the pieces. The only thing I need to know is this cosine. Cosine's an even function. So the negative 35 I can forget and just write it a positive 35. And so the only question is, where can I make some room to make cosine? Cosine is at even multiples of pi is +1. At odd multiples of pi is -1. This is an odd multiple of pi, so this is -1. And so the whole thing is this -1 and that -1 cancel, and I get 66 times 4. 6 times 4 is 24. You know how to multiply by 11? It's 24. So 264. Again, you don't have to simplify that pi. Did anybody get that for the derivative of P? Those that did this problem? Did anyone do this problem beforehand? Nobody did this problem. I hope I got this right. I did it very quickly. Okay, so we're not done. We want to know the equation of the tangent line. The equation of the tangent line at the point x equals 11. We know the derivative is 0. The point value is 0. So where can I put this? I'll put it over here. Y minus 0 is equal to slope 264 pi times x minus 11. That's the equation of the tangent line. that make sense? Did I lose everyone? Is anyone not lost? Okay, all right, that's promising. Did I find the equation for the last problem? Did it ask me to? Oh my God, it did. Always read the problems when you're done with them. Yes, it did ask me for the equation of the tangent line, and I did not find it. The derivative was 40. So and what's the value? And what's the value of h of f of g? So h of f of g at 1 is 11. F of 1 is negative 35. I'm sorry. H is f of g. This is f of g. G of 1 is 11. G of 1 is 11. F of 11 is negative 35. So that's the value of h of 1. H is f of g. And so the tangent line will be y minus negative 35 is equal to slope. What was the slope? 40? 40 x minus 1. Okay, everybody got that? Next. 4 minutes left. Six minutes left. Let's look over some of these. Some of them are going to be very, you tell me which ones you want to see done. Find the derivative at 3 if f of g is equal to x squared and g of 1 is 3. And so how would you do this? If we differentiate both sides of this, I get f prime of g of x times g prime of x. That's just the derivative of the left side. The derivative of the right side is the derivative of e to something, is e to that same thing, times chain rule 2x. Okay, and I want to know what f prime of 3 is. My only hope is that I'm going to evaluate this at x equals 1. At x, I'm going to evaluate both sides at x equals 1. That's my only hope of getting f prime of 3, because g of 1 is 3. So g of 1 is 3. G prime of 1, thankfully, they told us is 6. So I have f prime of 3 times 6 is equal to e to the 1 times 2, 2e. So now I know what f prime of 3 is. Let me not finish it in the interest of time. You divide by 6. Does that make sense? You see how you would do that one? You're given some partial information. My only hope is that I differentiate both sides. And then at what value of x should I evaluate things? Well, I know the value of g of 1, so that's my only hope. And I know the derivative at 1. So that's what's going to chain rule me over to f prime of 3. Good? Next. Okay. Consider the curve of this equation. Use implicit differentiation. You can differentiate. I would take logs of both sides of this. 5y natural log of x is equal to 6x natural log of y. Differentiate, you'll get a y prime in each of the pieces. Solve for y prime. I think you guys can do this, right? Next. Suppose that f is differentiable with these two functions. Evaluate the following derivatives. Again, annoying chain rule, and then you know what the value of f is at a third and at 0, and at what its derivative is at 0. And then you need sine inverse of 0, and you'll need cosine of 0 and things like this. I think you can do this one. I think you can do this one. I think you can do all of these. Do you need me to do these? No. Okay. Yeah, I left a lot of room because that looked like it was going to be a lot of work. Find the value of b. Let's do just the first one of these. If I know the derivative, okay, so what's the derivative of f? The derivative, it's a product rule. So let me differentiate the first thing. Negative sine of 18x, chain rule 18, leaving the second thing alone, b to the x, plus, now I leave the first thing alone, cosine of 18x times the derivative of b to the x is b to the x log b. And I know that the value at 0, at x equals 0, is equal to 7 if x is equal to 0. So if x is equal to 0, I get 7. Then when I put 0 in for x, this is gone. When I put 0 in for x, cosine of 18, cosine of 0 is 1. This is 1. This is b to the 0 is 1. So I get the natural log of b is 7. So I get that b is equal to e to the 7. Does that make sense how I got that? And then the other ones are similar. Just more practice. F is this. Find the derivative. Okay, let's do just this one. what's the derivative of the inverse function? It's 1 over the derivative of the value of the inverse function at 19. Right? The value of the derivative function of the inverse function at 19 is when is this thing equal to 19? That's a little annoying because I need to know when x cubed plus 10x plus 8 is equal to 19. If I subtract 8 from both sides, I get 11. Do I get lucky? Yes, x equals 1. 1 plus 10 is 11. So this is 1. And now if I know the derivative f prime is equal to 3x squared plus 10. Evaluated at x equals 1. At x equals 1, I get 3 plus 10 is 13. 1 over 13. Okay? Find the equation of the tangent line. Yeah. We know how to do that. Does that make sense? Okay. A rope. All right. Should we do this one last? Let's see. I guess I have three of these related rates. We probably only have time for one. Do you want to do a balloon or iron ball or a baseball diamond? Baseball diamond. Fine. Baseball diamond. Okay. Baseball diamond's got 90 feet on each side. 90 feet. Player runs from first base. Hopefully you know some baseball. I mean, this is some of you are new to this country and have never heard of this game before, but okay. This is a bad problem. I would not put a problem like this on the exam. Player runs from first base to second at a rate. So let's say the distance, let's say x is the distance to second. Distance from the runner at first to second base. Okay, because we know that the distance. Sorry? Is someone saying something? If you have to go ahead. Those that want to stay, I'm going to try to finish this last problem. So the distance starts out at 90, goes down to 0. So it's going to be negative 18 feet per second. Okay. Great. At what rate is the player's distance from third base changing when the player is 15 feet from first base? Okay. If he's 15 feet from first base, how far is he to second base? 75. Okay. And then I want to know what the distance is to third base. So let's call that distance S. S is distance to third base. Distance to third. What's the equation relating S and X? The fact that this is a right angle and this is 90 feet. Pythagorean theorem. 90 squared plus x squared is s squared. 90 squared plus x squared is s squared. The units are feet squared. Let me not keep the units. We'll put them back in at the end. So if I differentiate both sides, I get that 2x times dx dt. Differentiating with respect to t is 2s ds dt. The 2's cancel. X is 75. X is let me do this over here. X is 75 feet. Dx dt is negative 18, and s, I have to work out what s is at that moment. Well, s is the square root of 90 squared plus 75 squared, 90 squared plus 75 squared, and ds dt. Okay, so that's how we can solve for ds dt. Well, I would divide this to the other side, but yes. So the answer is the rate is negative 18 times 75 divided by the square root of 90 squared plus 75 squared. Okay, do you want to do these angles or you want to just go? Whoever needs to go, let me give you 2 minutes. Whoever needs to go ahead. Whoever wants to stay, I'll do B and C. So if you got to go ahead. At what rate are the angles theta 1 and theta 2? So this is theta 2. Let me draw a bigger picture. This is theta 2, 90. This is x. So we're going to do the problem. Yes. Yeah.
Yes.
No, just leave it as y minus. Yeah, any equation. I didn't say put it in point intercept form or something.
Also make it differentiate, we get a big expression there, but
Yeah, don't simplify if it's a messy expression.
like he would e to the power negative.
Yeah, if it's ugly, it's ugly.
Yeah.
Okay, let's do it. Ready? Let's do it. Okay, so what's the relationship between theta 2 and x? I'm getting tan of theta 2 because it's opposite over adjacent, x over 90 feet. Okay, so I put the 90 on the other side. X is equal to 90 tan theta 2. And this is in feet being measured. So now I divide both sides with respect to t. Let me separate this from, this was part A, this is part B. Now this is part B that we're working on. Dx dt is 90. What's the derivative of tan? Secant squared. Secant squared theta 2 times d theta 2 dt. Okay, what rates are the angles changing at this time? Well, secant squared, so this is when x is equal to 75. And so the hypotenuse is whatever this number is, square root of 90 squared plus 75 squared. Actually, there's a 15 in both of these. Anyway, let's not simplify. So secant squared, cosine is 90 over this thing. So secant is this thing over 90, and the square of that is 90 squared plus 75 squared over 90 squared times a 90 is just over 190 times d theta dt, d theta 2 dt. God, this is awful. That's dx dt, and we want to solve for d theta dt, so we just move that to the other side. It's not that bad, actually. Okay, so that's d theta 2. And should we do the last problem? We didn't do theta 1. I'll let you do that one on your own. The last problem, okay, I'll draw a new picture. The player slides into second base going 15 feet per second. Okay, you don't slide as fast as you run, I guess. And at what rate is the angles changing? So let's do, it's the same picture. Let me draw it over here. So when you're sliding into second base, that's when x is going to 0. Dx dt, what was the speed at which we're sliding into second? 15. So that's negative 15 feet per second. We still have this relationship between x and theta 2. What was it? Theta 2 is a tangent. So let me not do the derivative again. It's dx dt. This is just something that always holds. Oh no, yeah, this always holds. Dx dt is equal to 90 secant squared theta, 90 secant squared theta 2 d theta 2 dt. Okay, and when x is becoming 0, what is the secant becoming? This is 90. This is also getting very close to, this is square root of 90 squared plus 0 squared. This is also becoming 90. In other words, the cosine is becoming 1, so the secant squared is becoming 1. Secant with the angle is becoming 0. And secant of 0 is 1. So this is going to 1. This is going to 1. Dx dt is negative 15. And so d theta is negative 15/90ths radians per second, because now we've divided out the feet on both sides. So d theta, this is part C, d theta 2 dt is negative 15/90ths, which don't bother simplifying, even though 90 is divisible by 15, radians per second. I didn't get quite as far this time.